Hi viewers, my name is Priyanka from BSc Statistics from TSWREIS Budhwal. Now I am going to deal with the subject statistics. Let me define the word statistics. Here statistics means it is defined as the collection, presentation, analysis and interpretation of numerical data. Here the statistics deals with the data. If the data consists of one variable, two variable and more than one variable. If the data consists of one variable, it is called as univariate data, and the data consists of two variables, it is called as bivariate data. In bivariate data, we are dealing with two variables. Between these two variables may or may not exist a relationship. Suppose let's take one example. In the summer season, the temperature is too high. To overcome from this situation, the people will prefer coolers, ACs, refrigerators and etc. Here in the summer season, the demand of these products is more. Here, what is the relationship between summer temperature and these products? As to know about this relationship in statistics, we have the measures called covariance, correlation. Now, my concept is covariance versus correlation. Now, I am going to tell you about what is covariance and what are the types in covariance, and what is correlation and what are the types in correlation, and with an examples and difference between the covariance and correlation. Now, we are going to learn about what is covariance. Here, covariance indicates the direction of the linear relationship between the two variables. Here, it tells about the direction of the linear relationship. If there exists a relationship between the two variables, in which direction the relationship is in. Suppose here in covariance we have the two terms, one is co and another one is variance. It co defines some kind of joint action and the variance means variations between the two variables. Here in covariance we are finding the relationship between the two variables. If there exists a relationship between the two variables, how the relationship should be? That means it is in the positive way or in the negative way. We are seeing that here the change in the one variable affect the change in the other variable. We are going to find in covariance. Now let us know the formula. Here let us consider two variables, that is x variable and y variable. Here we are considering x variable as an independent variable and y variable as a dependent variable. Now we have to find the covariance between the two variables, that is x variable, that is independent variable, and y variable, that is dependent variable. We are finding the covariance between these two variables. It is denoted as covariance of x comma y, and it is calculated as the expected value of the product of the differences of each random variable from their expected means, that is expectation of x minus expectation of x into y minus expectation of y. Here we are finding the covariance by using this formula. Here expectation of x means expected value of the x variable, that is independent variable. Here expectation of y is expected value of the dependent variable. Now see this slide. This is the formula of the covariance, and in covariance we can also define the formula as sum of the deviations of the observations of each random variable from their expected means, that is summation I ranging from 1 to n and xi minus expectation of x into yi minus expectation of y. Here this is the formula given by n minus 1. This is the formula, another formula of the covariance. Here xi is the value of the independent variable and yi is the value of the dependent variable. Here already we discussed about the expectation of x and expectation of y. Here n is the total number of observations. Till now we have discussed about the covariance, and here in covariance we are finding the relationship between the two variables. Now we are going to learn about the types in covariance. Suppose let us consider two random variables, one is x variable and another one is y variable. Here we are seeing that if x variable is increasing, automatically other variable also increasing, that is dependent variable. Based on the x variable value, the dependent value is increasing. Here what's happening? The change in the one variable affect the change in the other variable. Here we saw that both the variables are in the same direction. In this type of relationship, we said that this is called as the positive covariance. See this slide. This is the positive covariance. Here in positive covariance, we are finding the relationship between the two variables, whether the two variables are in the same direction or not. Here let us see the example. Let us consider the x variable, that is independent variable, as economic growth, and we are considering the y variable as stock market prices, that is and if the x variable is increasing, there is a change in y variable also. If economic growth of our country is increasing, then we can say that there is an increasing in the stock market prices also. Here we are observing that the x variable is increasing and the y variable also increasing. Here we say that there is a positive covariance between these two variables. We can say that there is a positive relationship between these two variables. Now let us see the second example. We are considering the second example as x variable, that is independent variable, as size of the land, and the y variable, that is dependent variable, as the cost of the land. Here nowadays the land has more demand. If the size of the land is increasing, the cost also increasing. Here the change in one variable affect the change in the other variable. The change in independent variable, that is the size of the land, it is increasing, automatically the cost of the land is also increasing. Here we can say that there is a positive covariance between these two variables. Here let us consider the two variables, and we can also consider the x variable as independent variable and the y variable as dependent variable. Here we are considering x and y as dependent and independent variables. Here let x variable is increasing, then we can say that there is an decreasing order in the other variable. If x variable is decreasing, then other variable y is increasing. Here we can say that there is an opposite direction between these two variables. Here we can say that there is a negative covariance between these two variables. Here both the variables are in the opposite direction. Let us see the first picture. In the first picture we are observing that the people are climbing the hill. Here as the slope of the hill is increasing, the speed of a walker is decreasing. Do you agree with this? Yes, the slope of the hill is increasing, our speed of the walker is decreasing. And here we can say that there is a negative covariance between these two variables. Here we are considering the x variable, that is independent variable, as slope of the hill, and the dependent variable, that is y variable, as the speed of a walker. If x variable is increasing, y variable is decreasing, then we can say that there is a negative covariance between these two variables also. And here let us see another example. In the second picture, we are observing that this is a life cycle of a frog. Here tadpole is in one of the stage. If the tadpole gets older, the tail of it is smaller. So see the first one. In the first one, the tadpole is small and the tail is large. Here we can say, when compared with the tadpole with the last picture, that is the frog, we can say that there is no tail. We didn't find the tail there. Here we can say that there is a negative covariance between these two variables. Here you are seeing that there is a negative covariance between these two examples. In these two examples, the effect of change in one variable should be in the effect of the other variable. Here you observe that the change in the one variable affect the change in the other variable also. Here this type of relationship is said to be negative covariance. Here let us know about so till now we have discussed about the one is dependent variable and other one is independent variable. Let us consider the two variables, that is x variable as an independent variable and the y variable as an independent variable. Here we are considering the two variables as independent variable. If suppose let us take the example. Let us see the example as height and weight of a person. We are seeing that height and the character of a person. If the person's character is if the person's height is increasing, if you find any change in the character? No. Here this type of situation is said to be no covariance. In this type of situation we said that there is no relationship between these two variables. Till now we have discussed about the relationship between the two variables. If there exists a relationship between the two variables, how the relationship should be. That means either in the positive way or in the negative way. Now we are going to find about how strong the relationship is. That is, if there exists a relationship between the two variables, how the relationship is, either the strong or the weak. Now we are going to find. To find the strength of the relationship between two variables, we have the measure called correlation. Yes, now we are going to learn about the correlation. It tells about the strength and the direction of the linear relationship between variables. Here we can say that Carl Pearson defined the correlation as measure of the linear relationship between the variables, that is x and y variable. Here the correlation is defined as the r of x comma y, and it is given as the covariance of x comma y divided by sigma x into sigma y. Here covariance of x comma y means as covariance between the two variables, that is x and y. Here sigma x means it is the standard deviation of the x variable, that is under root of 1 by n minus 1 into sum of the squares of the deviations of each random variable from their expected value. Here you can see the formula. Here the formula is under root of 1 by n minus 1 into summation I ranging from 1 to n xi minus expectation of x whole square. Here this is the sigma y formula. Here the sigma y formula is the standard deviation of the variable y, that is sigma y is equals to under root of 1 by n minus 1 into summation I from 1 to n that into yi minus expectation of y whole square. Here these are the standard deviations of x and y variable. Here now we discussed about the correlation. What is correlation? In correlation we know about the how the relationship should be, that means either in the strong way or in the weak way. Now we have to see about the types in correlation. Now we can know the types in correlation. Here in correlation we have the three types. One is based on the degree of correlation, and another one is based on the number of variables, and another one is based on the basis of linearity. And here in degree of correlation we are having the two types. One is positive and another one is negative. Here positive correlation means it tells about the both the variables are in the same direction. Here you can see, here in positive correlation we are finding the relationship between the two variables that is in the positive way, that is in the same direction. If one variable is increasing, that is independent variable is increasing, there is a change in the dependent variable also. If independent variable is increasing, there is a change in dependent variable also. If independent variable is increasing, that is x is increasing, y also increasing. Here we can say that there is a positive correlation between these two examples. Let us see the example. By that you can understand more. Here we are considering the x variable, that is independent variable, as an x, and the y variable, that is dependent variable, as an y. Here we are taking the x as an height and the y as an weight. Suppose at the age of 14 the person's height is 4.1 and the weight is 41. At the age of 15 the person's height is 4.2 and the weight is 42. And at the age of 16 the person's height is 4.3 and the weight is 43. Here by this what you understood as, here the height is increasing. Here if the height is increasing, there is a change in the weight also. Here we can say that the change in one variable affect the change in the other variable. Here we can say there is a positive relationship between these two variables. Here you observed that. Let us see the picture, that is the positive correlation from the x variable. See the slide. From here the x variable as an height and the y variable as an weight. Here from the x variable the x is increasing and the y variable also increasing. In the picture we can say that there is a positive relationship between these two variables. Here x variable is increasing and the y variable is increasing. Here we can say the x is also increasing and the y is also increasing. Here there is a positive relationship between these two variables. Here as the height increasing, weight also increasing. If the correlation value, that is r is equals to 1, then we can say that there is a perfect positive correlation. Here now we are going to learn about the negative correlation. Here in negative correlation we are saying that both the variables are in the opposite direction. That is, if one variable is increasing, other variable is decreasing, or if one variable is decreasing, other variable is increasing. Here now we have to assume one example, that is, if a person wants to reach his goal by a car, what he will do? He will apply more speed to his car, and then he will easily reach his goal. Here what's happening means the person who is in vehicle, he is increasing the speed of a vehicle and the distance towards the destination is decreasing. Here we are observing that there is a diverse direction, there is a negative direction between these two variables. Here we can say that as the speed of the vehicle is increasing, then the distance is decreasing. Here we can say that there is a negative relationship, that is, if one variable is increasing, other variable is decreasing. The change in one variable affect the change in the other variable. Here then we can say that there is an opposite direction between these two variables. Here from the picture we can observe that here this is a picture of the negative correlation. Here the x variable is increasing and the y variable is decreasing. Here we can say that there is a negative correlation between these two variables. In the picture we can easily understand what is negative correlation. Now on the basis of number of variables we are having the three types. One is simple correlation, another one is partial correlation, and the third one is multiple correlation. Here the simple correlation means it finds the relationship about the two variables. Here it is as same as the correlation. Now we are going to learn about the partial correlation. Here in partial correlation we are finding the relationship. Here we are finding the relationship between the two variables after the eliminating of the third variable, that is after eliminating the effect of the third variable. Here in partial correlation we are finding the relationship between the two variables after the effect of the third variable. Here we are considering the example, that is we are considering the three variables, that is x1 variable, x2 variable, x3 variable. Here x1 variable is an marks scored in a test, and the x2 variable as GPS score, and the x3 variable as time spent for studying. Here the based on the other variable we are finding the relationship. Here we are assuming these values are, here we are taking the x1 variable, that is marks scored in a test, as independent variable, and the y variable, that is dependent variable, that is GPS scores, and the third variable is controlling variable. We are assuming the third variable as controlling variable. Here we are finding the relationship between the two variables after controlling the effect of the other variable. Here suppose if we get some marks in a final exam, the GPS score will be based on these marks. Here we are finding the based on the independent value, the dependent value should be. Here we are eliminating the, here we are assuming the third variable, that is time spent for studying, as a constant. That means we are controlling this variable and finding the relationship between the two variables. Here in this type of relationship we said to be, it is a partial correlation. Now we can know about the multiple correlation. In multiple correlation we are finding the relationship between the two or more variables on third variable or one variable. Here we can observe that here we are finding the joint effect of two or more variables upon a single variable. Here let us consider the example. Let us take the three variables, that is x1 variable, x2 variable, and x3 variable. Here we are taking the three variables. Here we are consider the x1 variable as weight, and the x2 variable as exercise, and the x3 variable as diet. Here we are finding the joint effect of x2 variable and x3 variable upon the first variable, that is weight. Here if you take proper diet and the proper exercise, your weight should be lost or gain based on these two variables. That means here we are finding the joint effect of two variables on one variable. If you take proper diet and exercise, your weight should be good, and if you take the normal, then your weight should be lost. It is based on the other variable. Here in this multiple correlation we can say that we are finding the joint effect of the two variables based on the one variable. Here we can say that this type of relationship is said to be multiple correlation. Now we will discuss about the no correlation. In no correlation it means, suppose we are considering the weight and the character of a person. Here also we are considering the two variables as independent variables. Here the first variable, that is the independent variable, as weight. If a person's weight is increasing, did we saw any change in character? No. If the person's weight is increasing, there is no effect in the character. In this type of situation, here the change in one variable will not affect the change in the other variable. This type of situation we can say that there is no relationship between these two variables, right? Yes, there is no relationship between these two variables. Here in this type of situation we can say that there is no relationship between these two variables. Now based on the linearity, we are having the two types. One is linear and the other one is non-linear. Now we are going to learn about the linear correlation. That is, here linear correlation means, here the correlation is said to be linear if the rate of change is constant. That is, the change in one variable affect the change in the other variable as constantly. Suppose by the example you can understand more. Let us take the example. Here we are considering let us see the slide. Here we are considering the x variable as 10, 15, 20, 25, and the y variable as 50, 55, 60, 65. Here you can understand that here the x variable is increasing by 5. Here as same as the y variable, that is the dependent variable, also increasing as same as the 5. Here you can observe that there is a constant change in between the x variable and the y variable. Here we can say that the relationship is linear. Here let us see the graph. Here we are considering the x variable and the y variable. Here we are plotting the points. Here from the graph also we can see there is a constant change in the picture. Here we can say that there is a linear relationship between these two variables. In this type of situation, the relationship should be linear. Now we are going to learn about the non-linear relationship. In non-linear relationship, the relationship is said to be non-linear if the rate of change is not constant. That means here in linear correlation we are taking the values as constant value, but in non-linear correlation we are taking the values are non-linear. So that is, suppose considering the x variable as 10, see the slide, x variable as 10, 20, 40, 65 and the y variable as 20, 45, 49, 60. Here we can observe that the difference is from the first variable is 10 and the next variable is 20. Here there is no constant change. Then we can say that in this type of situation we can say that there is a relationship between these two variables, but it not in the constantly. Here from the graph we plot these points in a graph. Here we get that there is a curve. That means here there is no constant change in between these two variables. Here the x variable is some values and the y variable is some values, but here there is no relationship between these, there is no constant relationship between these two variables. Now let us see the example and you can understand more what is covariance and what is correlation. By this you can understand. Here we are considering the x variable as an independent variable and the y variable as a dependent variable. Here the x variable as economic growth and the y variable as stock market prices. Here I am considering the data, that is economic growth in percentages and the stock market prices also in percentages. Let us see the data on the slide. And now we are finding the formula, that is our covariance formula is expectation of x minus expectation of x into y minus expectation of y. This is the formula. Here we are finding the covariance value. By finding the value, the answer should be 0.4. Here we can say that there is a positive relationship between these two variables. Here we can observe that the value is positive. Here the covariance value is 0.4. Here between these two variables, that is independent variable as economic growth and the y variable, that is dependent variable as stock market prices, between these two variables we can say that there is a positive relationship between these two variables. Now we are finding the correlation formula also. If we find the correlation formula, that is covariance of x comma y divided by sigma x into sigma y, we are finding these values. Here the answer should be 0.6. It indicates the positive value. And here we can say that we have to say that how strong the relationship is. Now we can say that there is a strong relationship between these two variables. Here if the r value is which is nearer to the 1, then we can say that there is an perfect positive correlation. We already discussed about the r equals to 1 value. Here the value r is equals to 0.6 means it is nearer to the value of 1. Here then we can say that there is an strong relationship between these two variables. Now if the r value is equals to if the r value is equals to which is nearer to the 1, then we can say that there is a high positive relationship between these two variables. And if the r value is equals to 0.5 if the value is less than 0.5, then we can say that there is a low positive correlation. Or if the r value is equals to in terms of negative, if r value is equals to in terms of negative, that is if r value is equals to minus 0.5 less than 1, then less than minus 1, then we can say that there is a highly correlation, then highly negative correlation. If the r value is equals to minus 0.5, which is less than, then we can say that there is a low negative relationship. Here till now we have discussed about the covariance and the correlation. Here in covariance we are finding the relationship between the two variables, and in correlation we are finding the relationship between the two and more than one variable. Here now we are going to differentiate our concept. Here my concept is covariance versus correlation. Now I have to differentiate what are the differences in covariance as well as in the correlation also. Here in covariance we are finding the relationship between the two variables, right? Yes, we are finding the relationship between the two variables. Is that here in this the direction should be the positive or should be the negative. When compared with the correlation, here we are using to find the relationship between the two variables. Here we are finding how strong the relationship is in. Here we are finding the relationship between the two variables and how strong the relationship is. Here we found that how strong the relationship is in, that either the relationship is strong or the weak. Here in correlation we are finding these. And now when compared with covariance, here it assumes the unit values. That is, suppose let us take one example. If x value, that is independent value, is equals to height, it is in inches. The height is in inches, right? Yes. If we are considering the y variable, that is the dependent value. If the y value is equals to weight, it is in kgs. Here it assumes the units. The height is in inches and the weight is in centimeters. Weight is in kgs. Here you are assuming the units. When compared with the correlation, Here it is an unit free measure. In this, here we are standardizing this value from the correlation formula, that is covariance of x comma y divided by sigma x into sigma y. Here we are standardizing these values. Yes. Now in covariance it can take any values from minus infinity to plus infinity. When compared with the correlation, it can take only -1 to +1 because we are standardizing these value from the correlation formula, that is R of x comma y formula. Here in covariance it is affected by the change in scale but not in the location. Suppose let us take one example. So if we multiply or divide any number with any number with one variable, the value should be changed in covariance, but if I add and subtract, the value won't be changed, that is location. Here in covariance the change in scale, here in covariance there is an effect of change in scale but not in the location. When compared with the correlation, if add, multiply, subtract, divide, there is no change in the value. This is nothing but the correlation. Now here covariance is a measure of correlation because here the covariance formula is used in the correlation. And the next, here correlation means it is a scaled version of the covariance. And at last the conclusion is, in covariance we are finding the relationship between the two variables. When compared with the correlation, we are finding the relationship between the more than two variables. This is called as the correlation. Here you can understand what is covariance and what is correlation and what is the differences between these two. Now I am saying my heartily congrats to Dr. R.S. Praveen Kumar Sar Garu and Dr. Balreddy Sar Garu and M. Venkateshwarlu Sar Garu and my mentor Madam Sri Priya Madam Garu and all my faculty members, madams, and my dear friends. Thanks to everyone.